Hello, Augies Worldwide. I'm Dave Casler, amateur radio call sign KE0OG, here with another episode of Ask Dave. Today we're going to look at something that came from KAIWEETS. That's this right here. It is an EMF Muti-Field EMF Meter. Let's take a look at how it comes. Okay, here we are. This is going to be my source of RF energy. This is a multi-field EMF detector. Let's look at the box. Okay, it'll detect magnetic fields, electric fields, and RF, but there's some things to note here. Range from magnetic 30 hertz to 1,000 hertz. So this is designed for an electric motor. Okay, at 60 hertz or 50 hertz. Electric, again, 1 to 2,000 volts per meter, again, from 30 to 1,000 hertz. Now the RF is very different. And you can see that this is really designed more for things like cell phones and microwave. The range can be changed. The frequency range that it will measure is 50 megahertz, okay, to 3.5 gigahertz. So let's take a look at this and see what is in the box. We have a nice case for it, which is a nice touch. And in the case is everything we need, which is the 3 parts. Here is the meter itself. Notice it's got a nice strap to hold it in. There is a USB-C cable to charge it. And there is a little manual, a user manual, which is in multiple languages. So although the manual is 46 pages long, the amount in English is 9 pages. So not very hard to read. The way to use this is actually pretty straightforward. I'd suggest you go ahead and charge it before you use it. This is a USB-C right here, and this is the cable for charging. So keep that cable charged up before you use it, which I've done. I've got this screen kind of a little brighter because everything's black, so it's a little hard to see. You turn it on right here, okay, and it is measuring 3 things. It's measuring the milliwatts per meter squared for RF, okay? And it's measuring milligauss right here. You can change from milligauss to microtesla if you wish, okay? And you can do either peak or max, all right? And this turns the beeper on and off. The beeper can be a real pain, so I'll turn that off. And the functions here puts the magnetic in milligauss up here. You hold it down, it goes to microtesla, okay? And then here now we have volts per meter up at the top, again for power line type fields. And then this one right here puts the milliwatts per meter squared in there. Now, I have noticed that while recording these things, for example, I have a little wireless microphone on here, and so it's picking that up. 29 milliwatts per meter squared. Now, if I turn on the radio right here, I'm going to give it 2 meters, and the 2 meters takes it way up into the red region right here. Now, notice the thing is somewhat sensitive to the polarized. How did the battery go down already? I've set this thing up with this little thing right here, so hopefully we can get some better color. This is actually gray. This thing right here is gray, okay? So what it's doing is it's receiving right now from my wireless mic. And so it looks like it's over. If I don't do the wireless mic or I step away, something like this, it turns back green again. Now note the scale here, 0, 1, 2, 20, 200. So it's linear up to here, and then it's quite logarithmic over here. So now, this is what it reads for milliwatts per square meter, which is the way we measure our RF. This down here, we get the microteslas, or you can change that if you want to milligauss. These are volts per meter is the electric field, okay? You can change between peak and max and just whatever it happens to be reading. You can turn the speaker off. You can see it's just beeping like mad, sort of like a Geiger counter. And the function, what this does is it switches these things around. This is the magnetic field, which is got to be less than 1,000 hertz. And then if you press the function key again, you get the electric field in volts per meter, and press it again and you get RF field. Now, we can play some games with this, and it says that all three directions are averaged together, but that's clearly not true. Okay, I'm just going to look here. We've got 11, and now if I flip it over to here, we've got a different reading. If I flip it up to here, we've got a different reading. It is definitely directional. So we take here our 2 meter transceiver. It's an ILUNS. This is 10 watts. And with that 10 watts, you really don't want this thing right next to your head. But I'm going to transmit now on 2 meters. Okay, it's gone way up here, okay. I think I realized what happened. If I overloaded this thing, see it's orange, there's red. So it's picking up quite a bit from the wireless mic. If I cover the wireless mic with my hand, it goes way down. If I open up, well, it comes up quite a bit. Now, if I give it a lot via here, note that the battery, it actually overwhelms the thing to the point where it affects the electronics inside to make it think that the battery is dead, and then it'll shut itself off. Let's try this, a somewhat different frequency. It's in 2 meters right now. There are some frequencies built into this thing. Okay, we're going to transmit now. Well, you can hear that hum in other things. Okay, the 0L means it's way over limit. Okay, it's over right there. Let me get a little ways back from it. Okay, it goes all the way to the max with that. So this is 10 watts of RF out, and this is why it's doing what it's doing. Now, I want to put this next to show a problem with these EMF meters. We've already shown that at different angles, it will measure differently, okay? In spite of the manual saying that it doesn't really do that. This right here is a little relative signal strength meter that I got from QRPguys.com. Their kits aren't available for any length of time, so you may not be able to get one of these. This is just measuring current RF. Now, if I were to transmit here, you see it goes up quite a bit. Okay, this is just strictly relative signal strength. Now, I have 2 other meters here. This is an Eric Hill, ERO2, and this is an EMF tester electromagnetic field by Olmo. Okay, it's an EMM2. Now I'm going to turn both of these on, and I'm going to turn off the speaker on each of them. Otherwise, when they beep, it goes crazy. Okay, this calls itself an electro-smog meter, and you can have it do something graphically or whatever you want. Now, I want you to notice right away, all of this is set for volts per meter. So let's go for RF in milliwatts per square meter. This is milliwatts per square meter. This is milliwatts per square meter. Note the drastically different readings, okay? And this, of course, is a reference type of thing. This adjusts the value, and this right here, you can hold it down if you just want to hold it for a moment, or you can turn it on, 9 volts supplied, could connect it to a larger antenna, or just use this little built-in antenna. Now, let's get our RF source out here and see what's going on. Okay, I'm going to hold it up here. I'm not getting a huge amount. That's anywhere from 20 to 40. This is 33, and this shows well over the limit. And this is milliwatts per meter squared. Goes up to 200, again in a logarithmic scale. Now, the wireless mic is getting in the way. I'm sorry about that. Okay, let's just try transmitting this way. This one's gone way over. This one's reading far less than this one is reading. We'll try it this way, vertically. This is actually the hum you're hearing is in the microphone as it is here. You see it builds a little scale right here. I'll just hold this right here. Okay, so it's up to 5 milliwatts per meter squared. This one over here is 60. All right, it's over what they call their limit. And this one right here goes way off the scale. Okay, so the question becomes, which one do you trust? And the answer, of course, is with any measuring device, they're all going to be different. So do you average them? Do you take the lowest, the highest, the one in the middle? I don't know, because these are not laboratory grade instruments. They're a little consumer device. It can give you kind of a relative difference, and it'll flash red if you hold it near something that is quite loud. I'll show you just one little experiment here. Okay, here we are on the overhead. I'm going to take this other wireless mic. This is the other Rode wireless mic, and I'm going to hold it near this thing and look at it. It's actually over the limit just because of the fact that it's a wireless mic. Okay, it's very high. We'll see if that does that on some of these others too. I'll turn this one on, and we'll hold it up here near this. Now, this is nowhere near the maximum for this. Turn it in a different direction. And we take this one over here, and we'll go with this. See, it goes up, but not to the max. Okay, whereas this one, very easily to the max. They have different sensitivities. What are they good for? Relative measurement, which is what this thing is right here. Let's see how much this KAIWEETS costs on Amazon. Okay, KAIWEETS Smart Multimeter EMF Detector. Right here, this looks like the right one. Let's make sure it really is the right one. EMF detector, okay. And they're less than $50. And it's got lots of pictures of the different kinds of things it does and the colors and all of this sort of thing that you can do like that, okay? And wow, discovering supernatural phenomena. It'll detect ghosts, look at that. And the last one there just shows all of the things that come with it. Okay, very good. All right, so there we have it. It's less than $50. It'd be a nice addition that you can use to kind of see where the RF hotspots are and things like that. So there you have it. Until we next meet, 73.